Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So this is going to be part 2 of the Harman Kardon 730 receiver. On the last part, we focused only on the power amplifiers, and we got that sorted. So we're going to get back into this. And this week's goal is to rework the power supply section and the amplifier sections. Okay, I think that's going to keep us busy all week on this one. I also want to leave the tuner section for another video. We're going to break that off and do that separately. So what I plan to do here is I plan to rework this power supply. We're going to remove these big can capacitors because they are definitely old and they need to be replaced. We're going to rebuild that. We're going to probably use a similar method as I did on my SR600. We're going to put some different caps in and we'll get that working. And another thing we're going to do probably this week is we're probably going to change all these capacitors. We'll just do it in the tuner as well. We'll just do everything while we got the soldering iron heated up. So if that's going to be interest to you, stay tuned and we'll see what we can do here. Let's open up the other side. I just tucked this away temporarily. I hate doing multi-part videos because no guarantee when I'll get back to a piece of equipment. Things are very busy here. I got a lot of clients that want stuff fixed. So like I said, these are power filters. These three are probably going to be all replaced. I'll leave the cans in place, but we'll stuff new capacitors somewhere in the chassis underneath. We have, like I said, we reworked our power amplifiers last time, and it is all working good now. So, okay, so here what we have is our power supply section right here. And we have a 2-winding transformer. Transformer provides plus and minus, I can't remember what the voltages were, but plus and minus, it's a split supply because the center tap is grounded. Okay, there's a secondary for lamps, and they're also providing a small circuit here for 6 volts or 8 volts. I can't read that, it's too tiny. So we have our positive supply here is a 3000 microfarad cap here. Our negative supply here, here's a 3000 microfarad cap. We're going to replace these with 4700s. And then we have a 120 resistor, 120 ohm resistor, and another looks like 200 microfarad cap, and it's providing, looks like 32 volts. I'm not sure. It's hard to read this, very tiny print. And then there's a cap on, where is this? Okay, so also they have a voltage doubler here because they're taking the AC, running it through a capacitor, a pair of diodes, another capacitor, I think that's 100, I can't really read it. This one looks like 200, this one looks like 100, and then we have plus 40 volts, plus 25 volts, plus 30 volts, and so on. And it looks like they're taking a tap off here and zenering it and providing plus 10 volts. So we have a few supplies we have to take care of. We got our main rail voltage is here. It is plus minus 25 volts. At least that's what I'm measuring on the amplifier when it's powered up. And then we have to deal with this voltage doubler circuit. And these caps here with the resistors, and they drop and then they filter, drop and filter. So let's start with this right now. Let's start with the replacing these caps. We have power supply is built basically in this one circuit here. Here's our secondary with the 2 red wires. This is our primary with AC 120 volts on this. This is got to be aware of this. This is high mains voltage here, so you can get electrocuted, shocked. So keep that in mind. It'd be nice to keep a cover on that when you're working on it live. So the 2 black wires is the primary, 2 red wires are secondary, and then there's 2 green wires here, and that is the other secondary. What is this white wire? Oh, that's the center tap. The white wire is the center tap for the 2 reds. Okay, and that's it. So what I'm going to do is there's a terminal strip here with these 4 diodes. I want to rebuild this one here to accommodate the 2 filter caps. I'll show you what they look like. So this is what I'm going to put in. These are 50 volt 4700. They don't need to be 50 volt. They could be 35 volts because I think the maximum voltage here is like 24 volts. And I don't think I have any 35 volts in stock. I'll see if I do. If I do, they're smaller size and they'll fit better. But we're going to work these in here somewhere. We're going to have them mounted, and the diodes will reconfigure that. And then we need to figure out these capacitors. This one here is our negative rail capacitor because it has the ground, the star ground here goes to the positive lead of the cap, and then the negative lead of the cap is isolated from chassis, and this is our negative, and goes to the negative portion of the amplifier or power supply. And then the other one is right here. This is a 3000 right here. The negative is connected to the star ground there, and then the positive is connected to the capacitor positive. And then we have a 120 ohm resistor going on to the next leg of the capacitor, and then there's a diode to ground. I think this is part of the voltage doubler here. I'm not sure. We'll figure that all out. But for right now, let's rip this apart and rebuild it to get rid of those 2 caps. One thing I don't like about this Harman Kardon is the wire they used. It's this heavy 12 gauge. It is stranded, but it's so stiff. It's like, why are they using this wire? It's almost like it's for an automobile. The insulation is not great, but that's what they had in the 60s. It's terrible stuff. So I'm pulling it out. It doesn't need to be heavy gauge like that. We're only dealing with a small amplifier here. It's not like it's a monster amp. Another thing I found out is I looked under this, took a peek under this tag here, and it was serviced September 15th, 1967. A little bit of. So somebody did service this, and I think I saw where there were some parts changed, like this. These 2 diodes were changed. That's part of what I saw as far as servicing. Okay, I just thought I'd take a break and give you a little update here. I've been doing some work, several hours actually. So I replaced a bunch of caps. Mainly these blue ones. All these blue ones have been changed. So yeah, what I found is if you change like some of these caps here, it opens up some room for these because it removes wires, it removes capacitors and other things. So I removed the bridge rectifier and a few other things. My plan is to use a bridge rectifier instead of the 4 diodes. I think it's going to be a little more tidy solution. My main problem here is space. So how do I install this? This is going to go here, I think, or like this. Haven't really decided on that yet. And I still have to find a location for these 2 capacitors. These are the 2 main filter capacitors for the B plus and B minus for the power amp. Okay. Yeah, so I removed a lot of stuff here. And well, actually these 2 capacitors have been completely eliminated. This black wire is a ground going to the star ground. That's going to be eliminated too. So that can come out. I'll have to run a separate, I'm going to use a separate wire for that. Basically all that's left to do is I have to recreate this circuit here. Now I really don't have space here to do it, so I think I'm going to drill out this rivet and put a terminal strip in right here, and that way I should have enough lugs and space to recreate this circuit. Some of these resistors are going to be replaced. They're out of tolerance. This cap's going for sure, and this 3-part cap underneath here is going for sure. So yeah, I need room for these components, and I think once I remove them off the capacitor, they'll fit on the terminal lug. Anything else? Oh, I moved. There was a circuit here. I moved down here. This is kind of like deja vu. If you watch the other episode on the SR600, I did move part of the power supply down in this corner because there's free lugs. There's 3, or actually 2 free lugs and a ground lug. So that's what that is. Spare ground wire I'm not using, I get rid of. This here is mains voltage. Got to be aware of that all the times. Keep wiring and components away from this. But yeah, it's coming along. Gone through and checking resistors here. Actually, so far I've only replaced 2 15 ohm resistors. They were out of tolerance. The rest of these check okay. Transistors check okay. So we're gonna get this finished and then we'll start doing some testing. But now I need to reconfigure this. I need to move some wires, drill that rivet out, mount this down, and start working on this night. This is the worst part right here, where you have all these big resistors. And get this sorted. There's 4 capacitors and 3 resistors, 4 resistors, 2 diodes, and it's all got to go onto this terminal strip here. So I'll start working on that. Alright, so here's a look after I'm done. It's a mess, I know, but really limited on space. This one here was the hardest to build. I had a 5 terminal strip here, and yeah, I got 4 capacitors, 3 resistors, 2 diodes. It was just it's a really busy area. But I got it all moved off. These are totally disconnected, these 3 capacitors, the 3 chassis mount capacitors. So I got all this redone, and I can show you the parts that I replaced are all marked off in pink. All the electrolytics. I replaced the 4 diodes with a bridge rectifier. I replaced one 680 ohm resistor. It was way out of tolerance. And that's it for this. And then I did a few in the audio amplifier. So now I just want to go and verify we have our voltages. Plus 40, plus 25, plus 30, 10, 22, and then our mains, our 2, what is this one? This is 23.5 positive. Oh, there's our negative. Okay. So let's go through and see if we can get all our voltages here. I'll plug it in. And we'll power it up for the first time. I hope we don't have any sparks or explosions. Oh, now, got to remember, this here is line voltage, right here and here. And it's already plugged in. See if I go AC volts. 8 volts there. 8 volts there. So it's coming in here. This is back here. You can't see it. But on these 2 outlets, there's also line voltages in this fuse. So if I check this, I got 8 volts. I'm referencing this to chassis. So everything's 8 volts to chassis. So this has been, that's the leakage that's coming through. So okay, let's turn it on and see what we get. Shoots up to 35 watts. We have our lamps are on. Okay. So this should be our negative supply, negative 24. Can you see that? That's better, I think. Negative 24, and this will be our positive 24. Okay. So these two are good. These two are good. Okay, 120 ohm resistor, and then it goes out 20.5. That's our plus 22 right there. And this one here, 10 volts, should be over here. We got 9.6. That's this one. Now, we have our voltage doubler, and it should go to 40 volts. So our voltage doubler, where is our voltage doubler? Right here. We only got 20 volts here. Okay, that's probably correct. But on the, which side am I? Oh, this side should be 40 volts. 40 volts, there it is. Okay. Next one up is through the 470. There is no 470 here. This is actually a 330. So I have plus 25. There's two 330s. Is it this one? Plus 27. Plus 36. Huh. I think this here is our, yes, our plus 30 supply is actually 32 volts. It looks like we have all our voltages. Plus 25 should be this one. Let me get 27. Okay, I think everything checks out. Now, here's a look at what I changed out in the audio amplifiers as far as parts. So I have two capacitors in each channel have been replaced, and I replaced a 15 ohm resistor because it was out of tolerance. These driver transistors, I'm going to go through and check each component one by one to make sure. But we need to figure out why we can't drive a signal through these amplifiers, and I suspect it is this capacitor here is a 15 microfarad, and this one here. Highly unlikely that both of them are open, but we're going to find out. And then there's another capacitor here, 2 microfarad, 2 microfarad, and these right there. So, and then we don't know if this transistor is working, and it should be supplied with plus 30 volts. So we're going to go through and check all of this, and we're going to try and pump a signal through here and see if we can get these amplifiers to work. But we need to find out why the signal's not getting through, and I have a feeling it's right in this section. This section all checks out. All these capacitors were replaced, but they're 100 microfarad, 30 volts, 35 volts, and I replaced them in kind. But they had not failed. They had higher capacitance than what's stated. They were up around 170, 175, somewhere around there. That's what they came out in red as. So let me get started on this section here. I'm going to start probing, and I'm going to check all these resistors, make sure we don't have any wickedly out of tolerance components, and then we'll get going on this. Okay, so I'm going through this amplifier stage. This portion right here I gone through yesterday, and I replaced 1, 2, 3, 4, 5, 6, 7 parts, and that's all in this little circuit right here. And it's really difficult to get in there. You have to use tweezers and needle nose pliers because your fingers don't fit. So I replaced all these parts, 3 electrolytics and 4 resistors. Now, as I'm going through, I'm testing parts as I pull them out, and I'm not finding a cause for why this amplifier has low output. I pretty much worked my way from this point up to the beginning here, where the signal comes in on this switch here, tone control in and out. Yeah, the signal's coming in, it's going through a bunch of potentiometers, and this is your tone controls, bass and treble, and then it goes straight into the amplifier. So yeah, I'm not finding the reason why this had all low volume, but we're going to get to it yet. Now, a couple things I did notice. C116 here, it says it's a 15 microfarad at 25 volts, and that was actually a 2.2 microfarad. And R177, which is a 2.2K, shows it right here, was missing. There was no, it was a direct connection with no resistor. And I'm also checking the transistors as well, and they seem okay. They seem okay from the point of the junctions are fine, but I don't know if they have missing gain or low gain, or maybe they're not working to performance. So I'm going to now focus my attention on this side and get this side complete, and then we're going to do some testing. Yeah, I'm finding a lot of these resistors here have drifted 10% or more. So that's why I'm changing them. Now, like I said, any one of these is not the cause for our low volume, but they can all add up. I don't think that's the case here. Seems like I did go through and check a bunch of these, and they were okay as far as resistors. So I'm gonna, like I said, I'm gonna finish this side, and then we'll do some testing, see what we got here. And that circuit is all right in here. I need to get in here and replace probably the same resistors, the same caps. These blue, or the teal, or whatever color these are, aquamarine capacitors. I really don't have a way to test them right now. They're low value, high voltage caps, but they're film caps. So hopefully they're okay. If any of these caps are leaking, then that could shut the circuit down, which is what I'm worried about. But we'll get to that in the troubleshooting if we still don't have a good signal coming through. Used film caps instead of electrolytics in this one, so I got 1, 2, 3 film caps here. Instead, I got rid of the electrolytics, so this will be stable for many years to come. Okay, here it is. It's done. I got the second amplifier. I got all the caps changed, resistors that were out of tolerance changed. It had less resistors than this one. A few of them I left behind, like the 2.2 meg was okay. I think that was it. But there was a couple over here. These were on the schematic. It says C76, C105, no polarity, 2 microfarad, 25 volts. In circuit, they were 15 microfarad polarized, so I replaced them with 22 microfarad bipolar capacitors. And you can see them right here. These two, and it's right between the tape monitor switch and the low cut. That's what that does. Okay, and the rest of these will be replaced. There's 6 of these new film capacitors in here that replaced electrolytics. Resistors were checked. Everything's within tolerance in this area. So now I think we can do a test. Let's power it up. There's no adjustments here. We should be able to feed a signal right in from the tape monitor and bring it right to the speakers without any hassle. Alright, so I'm set up to do a bench test here. Let's see, I have both channels of scope feeding a 1000 Hertz tone. This is DC offset on the output of one channel only, so we're going to see if that is behaving. I'm going to have to tweak this as we go. We're at 0. Let's turn it on. I'm getting some wild noises on that one channel. Some wild noises. Okay, I'm driving about 35 watts here. Let's tweak this a bit. Oh, it's settling. It's settling. No, it's drifting. Let's turn up the volume, see what we got. One channel's working good. The other channel is silent. Why is it silent? Bad switch. Bad connector. Okay. So we still have a dead channel. So if we take this up, hey, it's working really good. Now one channel. It's full volume. It doesn't even hit clipping yet. Okay, let's troubleshoot our one channel as to why we have no signal. But first, let's adjust this. I'm just going to turn down the bias on this one channel a bit. Okay, just got to keep cranking it. So I turn down the bias, it's getting closer to 0, and our power consumption is actually dropping a little. Okay, let's try the other potentiometer. Okay, we're down to 35 watts. Let me check the other channel. This one has no, yeah, it has a load on it. It does have a load. If I take the load off, it jumps up to 1.8. So, yeah, we got a load on there. Let's adjust this -1 first. A long ways to go here. And let's adjust some of this one. This one will actually make it go higher. But I need to adjust this one some more. Tiny little adjustment does not. Okay, I went too far. Let's give this one. Maybe my screwdriver wasn't bent. That's why it keeps falling off the set screw. That'll help. I don't know. Maybe it's time for a new screwdriver. Keep going down. Okay, we're at our neutral point, so we're at 30 watts consumed. We've actually turned down the bias on all 4 of these transistors, but that's not what the problem is right now. The problem is we have a dead channel. So you can see it right here. It's not working as designed. Let's see if we can figure out why. Let's get rid of this. We'll fine tune that after. Let's just get rid of this right now. Okay, what is going on here? So we do have both channels, as it seems. Okay, let's ramp this up to clipping. Let's see what we can get out of this thing. Okay, there's clipping. Let me get a little bit more. Turn my probes on. Alright, we need to measure AC voltage. Okay, it's turning it up. Let's see what it does. We might have to increase our input signal, because we are clipping on the bottom. Give this more oomph. Let's go up to a 2. There we go. You get lots of headroom now. Okay, there's our clipping. It's not symmetrical. We're going to have to adjust for that. It's not stable either, because the clipping point is actually moving around. Okay, let's measure the top. Right there, I'm going to call it on the top. And we got 9.2 volts AC, RMS. Let's do the other channel. Alright, let's take it up to clipping. There, back it off a bit, and we got 9.2 9.99 volts RMS. It's still a problem in the driver circuit. Look, if I turn it right up, you see the signal runs out of steam on the top of the waveform long before the bottom. Now, I think that is a function of the driver transistor not being, the output transistor not being biased properly, and I'll tell you why here in a second. Now, if you look at the bottom of the blue trace, you can see it's hitting the rail voltage, and that's, you can see that fluttering there, that's the capacitors. If I take it up on both, you can see it on both now. The top is cut off because it's missing the top end of that signal. You know, if I put my probe, let's put my probe onto one of the outputs of the driver. Now, if I start turning up the volume, you can see the top channel is what's coming out of the driver. I need to give it some more. Okay. Watch compare the two. You can see the top signal. The top of the signal is getting chopped. That's at the output of the driver transistor. If I keep going, you see how the bottom starts dipping and it starts doing this weird. That's actually the feedback trying to compensate for the clipping of the amplifier. If I keep turning it up, it gets worse and worse, and then it flat bottoms when I go far enough. It flat bottoms. So we still have a problem with our two driver transistors. They're not biased properly. Okay, here's the outputs, the driver for this stage. So we got a pre-driver, driver. This is a Class A amplifier. Runs through this coil. I don't know where it's getting its case. Plus 25 volts here through a 1K resistor. And then it's the transistor, and it's got a 15 ohm resistor to ground. Now this resistor measured over 16.5. So I replaced these two transistors, one in each channel. This point here says plus 13 volts. But if I look at my meter, I'm only getting 6.5 volts. See how it's not biased properly? Now, as far as I can tell, the only biasing of this transistor comes through this 150K, through the coil, and so on. There's no real connection to ground. There's two capacitors here, a blocking capacitor, so there's no connection to ground other than through this transformer winding. They say it's 150K ohm resistor here, but in reality it's a trim pot, and it's 250K. All right, and these were set about halfway, which probably translates to about 150K in resistance. But watch what happens to the current when I open this resistor up. I'm gonna do this with my fingers. It gets closer to that 13 volts. I can turn this. There's no... What happened? Killed it? Oh, no, my key. Put this back on. Okay. That's as high as I can go. I can't hit 13 volts, even though this is opened up to 250K. So do I substitute a higher value in and try and balance that? I'm going to measure the voltage through that 1K resistor, see what the current is. So we should have 13 volts across that resistor, and we got like 19. So what is the current through that? It says we should have 18 milliamps through that resistor in that transistor. Pretty sure I checked these values of these 1000 ohm resistors. It's 2 watt, 18 milliamps. 0.35 watts dissipation on that resistor. Can feel a fair amount of heat there. I don't know if that's 3.5 watts though. Oh. Just going to shut this off, and I'm going to check that resistance of that again, because it might be drifting as it heats up. That's what happened with some of these other resistors. They drift once they get hot, and that might be a part of the problem here. So let me check that. So here's the resistance with the power off, and it looks good enough to me. I don't know. That's how many ohms it is. 991. I'm thinking I might change these two trim pots to 500K, and we'll see if that helps me bring that close to 13 volt balance point. Let me put a 500K pot in here. Let's just do an experiment. Alright, so I wired in another potentiometer. This is a 1 meg. Wired it in series with that 250K, and we're going to see if we can get this to balance out. Now, it says here 13 volts, but that's assuming we have a 25 volt input. So what they're doing is they're going for half, right? So let's measure our supply voltage first, and we'll turn this thing on, and we'll let it stabilize for a while. Seems like it sure jumps around a lot when it's first turned on. So let's stabilize. We'll see what the voltage, supply voltage is. Seems like every time I turn it on, it's something different. I might have to look into that. So we're right around 26. So half of that would be 13. Okay, so let's monitor how this is turned on. Okay, so we have 6. Let's adjust this till we get. And remember, this one's set to halfway. It's 50%. I'm going to leave it there for now because I'm trying to determine what kind of resistor we should add in series. Oh, look at this. It goes right up to 13. Okay, let's let that stabilize. Let me try this again. See, now it's at 28 volts. So we should set this to 14, I guess. Let's turn this to 14. Let's give it a little bit more. Seems like it wants to run away on its own. It's drifting a little bit. 13.8. Okay, we'll leave it there. Not touching it anymore. So I'll take this pot out and measure it. Okay, I took it out and measured the resistance of that trim pot, and it was 300K, 305K. So I'm going to put a 330K ohm resistor in series with this trim pot. I'm just going to install it right now. And then we'll move on to trimming this up. I'll do both channels at the same time. Alright, so let's squeeze this in. Solder this. Okay, now just connect these two together. I'll just solder it and then I'll put some heat shrink over that so it doesn't. Okay. Yeah, I'll get some heat shrink on that. But let's set our biasing point. So we got our voltmeter connected, everything is good. Let's plug it in. And I've been setting it for 14 volts because it seems like the supply voltage wants to stay around 28 volts. Okay, so we got a little high, so we need to turn it down a bit, which means lowering resistance. Move the wiper. It's really 15 volts. Let's move it. Go in the right direction. There we go, 14 volts, 13.9. Actually a little too far, I can move it back up. Just a little bit more. Whoops, too far. We'll see how that settles. So my supply voltage is up here, and it's 28.3. Oops. So, yeah, we're going to go half, 14 volts. I'll leave it there and let it settle. Okay, I'll do the mod on the other channel as well. Put a 3030K in series with that pot. Alright, so I went through and made the necessary changes to the circuit. I added a 330K ohm resistor in series with this potentiometer. And then I made a 220K resistor in series with this potentiometer. I guess there's a little bit different gains in these transistors, so maybe that's the reason why. And that should put these transistors at the proper operating point for Class A. And what I mean by that is, let me see here. Let's use this one as an example. Let's just for the sake of argument, ignore this 15 ohm resistor. So you have a 25 volt supply, but in our case it's 28. And you have a 1K resistor, then you have a transistor. And try and visualize this transistor as a variable resistor that's controlled by the base. So we have a 1K resistor here and a 1K resistor here, approximate. We should get half the supply voltage on the output of the collector. That's what our target is. That way, when the AC starts coming in and starts conducting this transistor on and off, what it's going to do is it's going to want to turn the transistor on the peaks, the positive peaks of the signal. It's going to want to turn the transistor on harder. And on the negative peaks of the signal coming in, it's going to want to turn the transistor off from where it was sitting. So you've got an AC signal coming in, we have an AC signal coming out, floating on a superimposed 28 volt supply. So the middle point would be considered our zero, which in our case is 14 volts. And that's what I've set this to, is 14 volts. And then once you start applying AC, then you're going to start getting your maximum swing for that signal. And that way we can get maximum performance out of the output. Maximum swing here equates to our highest possible output on the output stages. So let's confirm on this collector and this collector that we have a signal, a nice clean signal that's centered around the 14 volt mark, and we'll see how this amplifier behaves when we increase the amplitude to maximum. Okay, so we're going to feed in a signal. I got an 8 ohm dummy load attached, so I plugged it in. Let's turn it on. And you can turn this on. Let's turn up the volume. Now, why do we only have one channel here? This thing's always flaky. I don't know what's the story with it. We got one input missing. What does this switch do? Causing a problem. What is that switch? That's the tone control switch. It's obviously really messed up. Okay, let's turn that out. Let's balance this because the balance control seems to affect a lot of different things here. Let's see. Turn up the volume, and we have let's see here. Okay, so we should have our one channel doesn't look very good at all. And there's our clipping. Seems to be a little more aggressive clipping in one channel. We're not getting a clean sine wave either on that one channel either. Something maybe's messed up. Let me check here. What channel is it? This one? Okay. That's maximum volume right there. So if I turn it down a bit, we get our output. Let's scope the output while we're here. Let's scope the output of the transistors and the output. Okay, so we got the scope probes moved to the output of the speakers. We're going to go up on volume, and we're going to see. We need to turn up our amplitude here. Let's turn that up. We'll see how much we get before clipping. About there is clipping. 8.2. It's even less than before. Let me check this transistor here. So the operating point of these two driver transistors is changing with volume. So I turn down the volume. You see how it goes wild and it has to settle? This is where it's ideal right now. So if I turn this up, what I think I want to do is I want to adjust this to bring that back up to 14. So let's try adjusting this. think that one transistor's damaged or something. It doesn't have the same gain as the other one next to it. Doesn't behave as well. We might still need to adjust the output transistors, the biasing on those. So let's do that next. Okay, onto the outputs. We want to balance this and provide bias for these transistors. How much bias do we give it? We don't know. But if you look at most common modern amplifiers, they bias these transistors roughly in the range of about 30 milliamps. What does that mean? Well, there's 30 milliamps of current flowing through the transistors to partially turn them on, just to get rid of that little portion of the transistor turn on curve where it goes from 0 to 30 milliamps. It doesn't transition well, it's not linear. And when you bias them on to be on the 30, turned on about 30 milliamps flowing through it, you're biasing it to turn the transistor on, so it's more in that linear portion of its operating range. So how do we do that? Right now we have 24 plus minus 24 volts, and we've already determined that 73 milliamps of that is going through these resistors. Okay, we do have to ignore that because it's really not any of our concern right now. It's just load on the power supply. What we want is 30 milliamp or 32 milliamp. Let's go with 32. That seems to be a nice number. So we're going to do that for both transistors. We're going to turn these two transistors on, and we're going to bias them for 32 milliamps. How do we do that? Well, the easiest way is just measure the voltage across this resistor and this resistor. Okay, so do the math. We know the resistance of this resistor, so it's 0.33 ohms times the 32 milliamps, 0.032, equals 10.5 volts, millivolts, sorry, 0.0105 volts. And that's what we want to measure across this resistor and this resistor. So if the current through this transistor and this transistor are equal, all things else being equal, we should have 0 volts on our output, and it's balanced and it's biased properly. If it's not balanced at 0 volts, now we can fudge the numbers, we can adjust one or the other to bring it either up or down to bring this close to 0 or as 0 as we need to be. So let's go down and do that. Let's power this up and let's get a voltmeter handy and we'll start adjusting. Okay, so we're all hooked up. Let's power it on. Where's the power switch here? And we'll just let it voltage up and settle. I'm measuring across the first 3.3 ohm resistor, 0.33 ohm resistor, sorry, and we got 54, so we got to really turn this one down. And I do have a 8 ohm load connected to the output. Turning these transistors off. Right now my consumption is at 24.8 watts overall. So let's see what we can do here. Just keep going down, down, down. Let's stop about 25. And we'll do the other transistor while we're here, just to keep them kind of close to each other. Okay, let's turn this one down as well. screwdriver is useless. Okay, I went too far. Let's start with 20. Let's turn this one. Okay, this one dropped as well. Seems like that's as far as it wants to go. 19 millivolts. Let's leave it there. Come on. Okay, let's go back to this one. $19. Okay, so let's check our output for 0, and then we'll tweak it. Maybe that's as low as we can go, is 19. So where is our output? Right here on this one. So we're only 15 millivolts. That one takes it higher. Okay, I'll leave it there. So that's zeroed. If I shut the speaker switch off, it kind of stays at 0. $50, $51. It's floating up and down. So let's keep the speaker switch on. Okay, power consumption is now down to 20 watts. Let's do the other channel. Let's do this side. All right. Take it around 20 millivolts as well. Maybe that's going to be our base measurement for bias. Okay, let's see here. $26. Let's turn this one down. Right about there. Let's check our 0. Okay, I'm back. I replaced this clip lead. It wasn't behaving. Plus I was probing on the wrong spot here. I had the wrong resistor. So that's my goof up. So this is 0 balance right now. I'm trying to adjust. So let's adjust the 0 balance. Got 115 millivolts. Zero balance right there somewhere. Okay, shut the speakers off. And it stays around 1 point some millivolts. This is our power consumption for the whole unit. It's 19.5 watts. So we've adjusted these to be 20 millivolts instead of 10.5. So we upped the current actually by double. So we have approximately 65 milliamps or so along here. If I measure it, Measure this one's 20, I believe. 1985. And this one here is 1992. This one down here, 20. So we got them all pretty balanced. Let's do a power test to see how it runs. All right, I'm going to do one last power test, and this will be the last one for this video. I just want to confirm that we have, turning it on, just want to confirm that we have everything 100%. So here it goes. Let's see how this does. The top one is already clipping. So which one are we measuring here? We're measuring this one here. The top one. Okay, so let's go with the top one. Let's try and get an accurate measurement here. And what do we got? 8.2 volts RMS on the output. Let's try the other channel. Let's go a little bit. Right about there. We got 9.1 volts RMS on the output. Not a big powerhouse, that's for sure, about 12 watts, more or less. But that is it. Let's try different frequencies. Let's try upping the frequency here. 11 kilohertz. 17. 27. It's holding up well. Doesn't look great. Now you got to remember, this is part of the transformer that's distorting our signal. Amplitude is good, but it's just getting a really ugly distortion, especially that top one. I'm not happy with that top one. Maybe I got a damaged transistor there. It's this one here. Let me get a little freeze spray and see if that gets any action out of it. Okay, keep an eye on that top transistor, or that top trace. I'm going to freeze this transistor. Seems to get worse. It's got a little bit of oscillation too. Heat that up. It goes back to normal. Let's try this other one. It seems to have no effect. I'm suspecting this driver transistor is kind of on its last leg. The other NPN seems stable. Okay. So we're at, what are we at, 11 kilohertz. Four kilohertz. And we still have that little distortion on that one channel. There's the little low end, 10 hertz. 10 hertz looks pretty good. Turn it into clipping. I got the tone controls on. There's tone controls off. A bit dirty switch action. 20 hertz. Definitely got a bad switch here. Okay. Pretty good, considering what it is. It's 20 hertz. Up and down in volume. 30. I might experiment with changing these driver transistors out. Just not happy with their performance. This one's getting hot. This one's staying cooler. Okay, so there it is for this week. We completed the rebuild of the line amplifiers, driver amplifiers, whatever you want to call them, and then we reset the bias for the output transistors, reset the bias for the driver transistors and outputs, and did some cap changing, rebuilt the power supply. Proof of concept that last week when we changed those transistors to silicon, they're working fine, and got them dialed in. It's working quite well, I think, right now. I still have a hiccup though on this one channel. It displays some odd behavior once in a while, so I'm gonna keep an eye on this, and it keeps acting up. I'm gonna dig deeper into this one channel. I think it might be damaged, but I'm not sure. But that's it for this week. Going to attempt, well, we still haven't done the phono stage. It's down in this area here, and we still have to do the tuner. We haven't changed any caps in that yet. So that's going to be another episode in itself. And then we have lamping to do, and these switches are a joke. We have to clean these, relubricate everything, the pots, switches, and then see if we can finish this one up. Maybe next episode. I don't know. We'll see. So anyways, thanks for watching, and take care, and we'll see you on the next one.